Hello. Let me check if it's recording. Yes. So hello. In this video series, I don't know what to call them, but they're live records of me doing some programming related stuff. They're not planned, they're not scripted, so everything could go wrong. We could fail in achieving what we wanted to do. I tried to do some searching before to see if what we want to do is possible, but for the most part it's unscripted and we cannot anticipate what's going to happen. So in this video, it might take more than one video, but I try to achieve something I want to have a presentable output. And sorry for my bad English. English is not my native language, so I am probably just right now speaking wrong, but that's it. Nowadays, for these past few weeks, I've been playing around with Zig. Zig is let me open the website. Zig is a new programming language, relatively new. It started, I think, at the end of 2015. Actually, I have their Git repo, so let's just check that out. And see what's the first commit. Yeah. The first commit by the language author, of course, is at the August 5th of the August of 2015. Yeah. So it started at 2015. It's a new system. I'm not going to call it system. Let me just put this in here so I can check everything, recording and everything. So Zig started as the author and the creator says, as a replacement for C. The author wanted to have a better language to do stuff that only C could do. So why he chose C for some projects? Because C doesn't have any runtime. So it's almost predictable, and everything you do in a C code, almost everything, you could do some weird stuff with macros, but most of it are your code doing stuff, not a GC or a runtime doing some stuff for you, doing some allocations. For example, I come from a background in Golang, and in Golang you have a runtime. It's embedded in your executable, but it's there. So it's doing the garbage collection, it's doing the memory management, it's doing the scheduling of the Go routines, so many stuff. So you cannot use Go, for example, for a project like writing an operating system. You cannot use it. You cannot use Go for scenarios that you want to deploy your application on an embedded device. Same as you cannot use Java or other managed languages like C# and other ones, most of popular programming languages. So Zig was started with this idea, and also being simple. So before Zig, I was playing around for some time with Rust. Rust is a great language if you want to look at it from a language design vision, language design perspective. We can see that Rust is an amazing language. The type system is just amazing. It took many pages from Haskell and functional programming languages and type theory from those languages, but it's complex. And I see these two programming languages as, choosing their users. Rust chose C++ users. It has so many features. Zig does not choose C++ users. Zig is choosing C users, and people and I feel other people from other programming languages that want a safe, almost reliable, and easy to use everywhere programming language can come and use Zig, especially C people, but not just C people, because it has so many modern and new features that some of them are not actually found in any other language, at least to my knowledge. So if you take a look at Zig website, it says it's a general purpose programming language, exactly. Toolchain for robust, optimal, reusable software, okay. It says it's a simple language. So there's no hidden control flow, no hidden memory allocations, and no preprocessor or macros. Zig doesn't have any kind of garbage collector or memory management piece of code running without you knowing it. And how Zig does that is using, actually that's one of the nice parts about Zig, because Zig uses so C and C++, they didn't have any kind of approach for memory management. It was completely manual. Rust came and brought the idea of ownership, so the compiler would generate the code that will allocate memory, deallocate memory, all those stuff, using its type system. So when Rust compiler looks at your code, if your code is correct and it's compilable, Rust compiler will add bits and pieces of code to your code that will allocate and deallocate stuff. But Zig, on the other hand, neither the compiler or language has any kind of special syntax for doing this. There's nothing. There's just one concept in the standard library, and that's called an allocator. And every piece of code, every struct, every function that needs to allocate stuff, needs to allocate memory, we'll use one allocator passed into it. An allocator in Zig is kind of an interface. There are multiple implementations of it, and we will see the most used one when we will start writing the code. Zig also is Zig has a comp time feature. You can run and evaluate some expressions that compiler can evaluate them in the compile time. And this is really powerful feature because it basically enables Zig generics without even trying. And we will see that as well. Zig also has a build system built into it. So, and it's far better than using than the competitors like CMake, like having to build script. And I'm not coming from a background in C, but as a user that sometimes I just poked around with C or C++, I really find Zig so far better. Zig is also a C and C++ compiler. You can compile. They basically ship Clang inside Zig, and Zig also uses LLVM to generate the machine code. And you can also import C header files in Zig code. And you can use basically, I think most, if not say all, but most of C libraries inside Zig. And I have a plan to create a video and see how we can use SDL2 to create a simple game. So in this video, we are going to create a web server in Zig. Sorry for the disruption. I had to answer one call. So yeah, I was saying that we are going to create a web server in Zig in this video. And what is my plan for this web server? Every code that we write in these videos is going to be open source on my GitHub. I will link my GitHub down in the video description. Let's create a repository for this. I'm going to call it Khadem And Khadem means someone who serves you, and it's a web server, so it suits it. So I will create the repository, and yeah, let's copy it and clone it. So let's go to my personal folder. Let's clone this. Okay, let's go into it. So we have an empty repository. Let's initiate a Zig project. So I do Zig. Let's see what available commands we have. So we have some init. We should use these. I'm gonna create an executable, but I'm planning to have it as a library as well. So another Zig programmer or another Zig project can import this project and use its web server. I'm gonna tell you what my plan is, but let me just start the project. Okay, so let me show you the file tree. So you see the Zig project is really simple. I mean, compared to other competitors in this area, it's just a build.zig file, which is the build script written in Zig. So I told you that Zig is a build system, has a build system built in, and it doesn't have any kind of weird syntax or even using popular formats like, I don't know, JSON or TOML or anything. It's just code. You can configure your build with code. And also some main files, probably some hello world. It is a hello world, and we will see what's in it, but let's start with this file. Let's go into build.zig. We see it has a public function, and you see that syntax of Zig is really familiar to anyone who used almost any kind of programming language. It's a public function called build, and it takes a build.builder and returns nothing. That's how you define a function. There are some things. What's the target? And this is probably the default target that my machine is running. It's probably Mac and ARM64. Release options. What is my release type? There are I think there are 3 release types and 1 debug. I think 4 release modes are available. Yeah, actually there is a comment on top of it. So there's debug, there's release safe, release fast, and release small. And you just add an executable to it called Khadem. And the source file for that executable is in the source main.zig. And that's basically it. You can define steps for your code, for your build system. So I can say Zig build, it will run this script, and then one of these steps, run or test. But let's go into main. So as you see, main and all Zig files, probably all of them should import std. This is how you import something in Zig. You import a namespace, basically, or a package, and you can configure this in your build.zig, and you can add other stuff in it as well. We will see that in other videos, but in this video we are probably just going to use the standard library of the Zig. We have a main file, and also tests are in the same place as the source code files. You can just create a test block, and you just I was speaking Farsi for I just spoke one Farsi word. So yeah, and you just expect something, but we don't need this. So I will remove this. Let's just run this for now and see what's happening. So Zig build run will generate this message for us, and you see that the second time it's going to be a lot faster because Zig uses some caching for the compiler. And you see I have now a Zig cache and Zig out. Let me try to make my Vim respect my... I don't know what's wrong with my Vim. For some reason, it decided to not respect my git ignore, and I don't know why, but okay. I will debug that later. So, what's our plan? So, for this project, I want to have, this is not how you do a comment in Zig. I want to have a web server, right? So what is a web server? Web server is basically a TCP listener plus HTTP protocol implementation plus some handlers. Basically, that's it. So for the TCP listener, we have it in the standard library. It's so easy to use, so we will use that. For the HTTP protocol, we are going to do it by hand, and for the handlers, I want to have them both. I want to be able to both pass functions, and I really don't know how to do it. I really don't know how to pass functions and, you know, call functions that are inside a variable. I don't know. We should look that up in the Zig specification. Implementation of HTTP protocol is not that hard. Okay. So, and also I want this to be async. And Zig right now supports async stuff using event loop and async await kind of style of coding. But it's really better than the competitors, and I will show you why. But let's start. So, yeah, I want to have, so I told you I want this library to have two ways of using it. First, library. So you create a web server with config, with some config. Second way of using this project would be to using it as an executable. The same way you use, for example, Nginx. And the executable gets a config file in, for example, I don't know, maybe YAML. So that's how our users are going to use this library. Okay, so let's start with creating a simple TCP server. So I'm going to import, so I've already imported all the standard library, but I'm going to import net, which is a sub, I don't know what to call them. I don't know what Zig calls them. Module, sub, package, some sub something called std. I think it's an std net. And I want to have a stream server, which is basically the TCP server of Zig. So it's net.stream server. So stream server and probably address. Net.address. So let's start. And I can use just use this in my code, but it makes it cleaner to use it like this. And if you notice something, I'm really excited about Zig, so I'm gonna brag with its features. One of the things that is really unique to Zig, I think, or I have not seen a lot of languages doing it, is that Zig types are values themselves. So the type of a variable or type of a data, type of a value can be type itself. So these, you see, this stream server is a struct, but it's a type. You can instantiate it, and we will see how. So let's start creating a stream server. Most of Zig objects, structs, have an init and a dinit, which is the destructor for that. Okay, so let's start. Let's see what what it gets. So it gets an options. It gets some options. We can go into it, and Zeek has a language server, so this is what makes it possible for go to definitions and stuff. And we see the options defined here. Kernel backlog, how many connections the kernel will accept on the application's behalf. If more than this, make connection pools. Many connection pools in the kernel. If more than this many connection pools, the kernel will start seeing connection refuse. Okay, I'm not gonna touch this, and these both have default values, so I'm gonna respect them. So I'm just gonna pass an empty struct. I can do net.streamServer.options, and this is valid as well, but I'm gonna use Zeek. I'm gonna let Zeek infer what to put in here. So I'm just saying, you know what you should put in here. I just want an empty one, empty of the default one of it. And I can, if I want it, I can pass stuff in it like this. But I don't want. So let's do it. Okay. So init returns an stream server. And this has a listen and accept. The language server can be improved because, for example, this init shouldn't be shown to me when I have when I've already instantiated a stream server. So listen should be shown because it takes self, so it's basically a method. So I'm not gonna try to listen to it. So I just have my stream server. If I can type. Also, for the stream server, we need an address to listen to it. So we create a address. I think it was with resolve IP. There are multiple ways of doing this, but I think resolve IP is the high-level API. If you take a look, yes, it says, so it says if it's IPv4, just do it. If it's IPv6, do it. There are specific ones for, I don't know, what's the difference between parse and resolve? Resolve, does resolve IPv6 and IPv6? I don't know. I'm just gonna use resolve, but I think the other one would work as well. So passing, Zeek doesn't have any kind of specific string type, or strings are just slice of bytes. So this is a slice of constant U8, which is a byte that is immutable. The byte itself is immutable. A string is mutable. And a port. Okay, I'm gonna pass my local host. Okay, what's wrong with my editor? And I'm gonna pass in the port. So this would return, and this is the one of the important aspects of Zeek. We are calling a function that returns bang address. Bang, or exclamation mark, I think, shows that a function is returning either an error or this address struct. So this function can fail. And for handling failure in Zeek, we do try. This is not an exception. This is just value. This function basically returns some kind of, I don't know what we call them in other languages. I think it's a monadic type that it's either address or an error. There are other syntaxes for this, but this is the simplest form. You can catch the error and, check its type or its value and do some stuff. But try just means that, okay, call this function. If it's the value and nothing fails, okay, just assign the output to this address, right? This address constant I have. If not, if it failed, just return the error. And you see my main can also return an error. Okay, let's move on. Let's start our stream server. So not init, we already initted, so we need to pass the address. So now our server is going to start listening to traffic. Cool. Let's do stream server.defer So we close this, stop listening. It says it is still necessary to call the init after stopping listening. Okay, so defer means at the end of this function just call this. So now we are listening, and I want to show you some cool stuff about Zeek. This is about the async one. You see that in here, it's defining a constant non-block, and it checks if standard IO is async, do this, else 0. So what does this mean? Zeek can be run, it can do async await stuff in a global switch. It's really important. Zeek does not have any kind of specific keyword to mark a function as an async function. Zeek solves the coloring problem in other languages. So if I want to have, let's say, a handler for traffic, and I want this handler to be async, I don't need to make this like other languages, async function something. It can just be this, and Zeek decides what to do based on the global switch. And the global switch is basically, you need to define a constant called IO mode in your main file. So now, basically with just this one line, I made my server async, which is really nice. Okay, sorry again for the disruption. Someone was at door. So let's continue. Where we were at? Okay, so we defined the global switch for the IO, so it's now evented using the internal event loop in the standard library. Let's start. So now this listen is non-blocking anyway, but let me show you where it's the actual magic happening. So I do a while true. Let's do stream server dot accept. So this accept would, I think, will this become async? I don't know. Take a look. Yeah. You see that is accept has an if it's async, it's using the loop, which is the event loop inside the standard library, and using that tries to accept the socket. So let's we just need to, okay, we pass it nothing, okay, and it returns either an error or a connection. Okay, so let's do try. It will return a connection class. What does this connection have? It has an address. It's not important for us, and a stream. And probably, yes, on the stream we can do write and read. There's a writer and there's a reader, and these are both some kind of interfaces. There's no concept of interfaces in Zeek. There are just, structs that have some configurable functions that should be defined in them, and they have the behavior. So for example, we have a reader struct in the standard library, and every part of the language, every part of the code you want to use a reader, you should pass some of those functionalities that are polymorphic to it. So let's just write on that connection actually. So I get my writer and I use print, and let me tell you a truth. I have played a bit with the TCP server in the Zeek. That's because looks that I know what I'm going to do, but that's basically the only thing I've written in Zeek. So in other videos, you're probably just gonna see me stuck and don't know what to do. So we do print, we pass a format string and some arguments. Hello world from Zeek. No need for any kind of arguments, and this is the same thing. I think this is not the same thing. This is kind of called tuple or tuple. I don't know what's the correct pronunciation, but it's the same thing. Oh, let me mute the system. So yeah, so notifications like that won't make your ear bleed. So we have a try of this, and this does not return anything valuable to us. Yeah, so it either return an error, and you see that it can define the specific type of the error. Any error, or just removing any error and just put bang something, it means all error types. All error types. But restricting it actually is better, because user knows what to check for. If I wanted to handle this error, it's really better to know what error could happen in here. So it will print, and then I will use connection.stream.close. So let's see. How should I run this? Okay. So let's go into my repository. Let's do zig build run. We get a compile error because stream server should be a variable, not a constant. For some reason, when I'm decided, when I want to close it, it needs to be a variable. Okay, we make this a variable. What was the key binding? Okay, let's run this again. Oh, we have, listen returns an error. Yes, it's correct. So we should do this as well. Hopefully this will run now. Yeah, it's probably running. What was the address on the port? Localhost 8080. So let's try that with nc localhost 8080. We should get a hello world. Cool. That's so cool. So we get a working TCP server. That's a good start. Let's move on. So to make this a bit better, even now, I'm gonna make a handler function. So I'm gonna have a function that is a handler called handler, and I'm gonna pass the connection to it. So what was this called? What's the type of this connection? Oh my god. Or actually not the connection, just the stream. I don't think, I just want the stream. So stream, and that's net.stream, right? And this function can fail for some reason. Yes, for this reason. So let's bring this in here, and okay. So, and yeah, let me do this in here. And defer the string close, and we do try handler of connection.stream. Let's see if this works as well. I have a fear, but okay, it's working. So when I was playing around with this before, I had a problem in my code that the connection didn't, the listening didn't stop, so the OS wouldn't let me to use the same port. But now it seems that defer close is working. So let's run this again. We get the same result, but it's now a better one. So now we have a handler function that does all this stuff that does all the things we want. So what's going to be next? I want an HTTP server. So we should probably get on with parsing the request. Yeah. So let's take a look at what HTTP requests are basically. Actually, let me do a commit. Okay, why this is not, it's actually respecting that. Yeah, git ignore. Let's zig out. Okay, looks good to me. Let's add and commit. So initial commit, basic TCP and push. So this is our first commit on this repo. And let's go to main again. So I have a question actually. Is it async now? I don't know. Is this async? What by async I mean to, just call handler and forget about it. Because the handler is basically just handling everything about the connection. We will test that later, but now let's focus on parsing the HTTP. So HTTP, if you take a look at the Wikipedia of the HTTP request, the request is a multi-line, basically. There is the first line is method space URI space version, followed by a carriage return. So basically \r \n. \r \n. So line feed is actually \n, right? It's a line break. Can I see the? Can I make sure? Yeah. So the LF. So carriage return and line feed is \r \n. Okay. So there is the \r \n. There are 0 or more headers. Headers are in format of. Oh, it's already 36 minutes. Oh, I'm so slow. Host colon space and the value. Okay, this is. Oh, it's an optional. That's not cool. Make it strict. Do not make your protocols have optional stuff in it. I mean, this is not a useful. This is not a useful space. Why should we have it? And okay, how we can. Okay, so 0 or more. So how it ends. Oh, okay. So there is an empty line. Only a carriage return and a line feed, and all of these are ending with the same characters, 2 characters. And finally, we have the message body. Looks cool to me. Let's continue. So let's start reading something from the request. So stream, we know we should access reader type, reader function, returns a reader. What we can read, there are a lot of functions. So let's see, there is a read all. We can pass a buffer, and then it returns the red number of the red bytes, count of them, basically. We have some functions. These are not for us. Oh, read struct actually looks fun. Let me see. Only extern and pack struct have defined in memory layout. So we should have an extern struct, which is, I think, it is also accessible in C. Yes, you can. I forget to mention that you can call Zig code from C. This is really powerful. I mean, Zig and C relation is almost like the relation of Kotlin and Java. Okay, this is not useful for us because we don't have any kind of struct. We can have later for request type, but not now. Okay. So read until delimiter. I think this is cool. And read until delimiter, it will pass a buffer to it. I don't like to pass a buffer. I just want to read everything until the delimiter. So it's not important for me how much space it's going to take. There is a read all alloc. Returns a string buffer. Returns basically a string. So alloc means it takes an allocator. This is how Zig does memory management. Because this function needs to allocate this slice, it needs an allocator. So I'm actually I don't know what to choose between this one, read all alloc, and read until delimiter or EOF alloc. Read until delimiter alloc. Yeah, I don't know which one to use. Oh, this is nice. This one is actually really nice. It says replaces contents by reading from the stream until the limiter is found does not include that in the result. So basically it reads, so if I say my delimiter is \n, it will read line by line and returns an array, returns an array list for me with those lines in it. Let's use this one. And I have not used this. So this is the part of the stream that everything could go wrong. Okay, so the array list, I should allocate an array list. Do you need an allocator as well? No. Okay, so I should create a allocator so I can use it. And I want to use a single allocator for all my project. So let's use general purpose allocator. It's in std heap general purpose allocator. Cool. Yeah, there's an error in here. It's not important for me now. So let's create that. So var, I know general purpose allocator should be a var GPA general purpose allocator, passing a config, again not important, instantiated. So GPA type is general purpose allocator. I need to create a allocator, kind of object from it. So allocator is GPA.allocator. That's pretty much it. So, and I should pass this allocator in here. And now I should create my array list. Var lines is standard array list. Let me show you how Zig does generics. Zig does generics since it has compile time code execution, and we will see probably more of it. Zig has compile time execution, and it can do for function arguments. So if a function argument is marked with comp time keyword before that, the compiler would basically somehow generate, when you call that function, it will basically ignore that in the runtime. Not like this. It will create an instance of that function that this value is basically put into that function, and there's no need. So basically this array list, if I pass a type in here, let's say I pass a usize value, when I'm calling this function, the generated code, there's no knowledge about what this comp time mean is, and in the body of the function, everything that is this t is replaced with a usize. Basically this is how generics works. I probably did the explanation wrong, but I mean, to be fair, there is no documentation yet, at least I didn't found, so that's my understanding. This is like this is like doing this in Java, or doing weirdest syntax of all time in Go, the recent generic stuff added to the language. So I want an array list of strings. So constitute. What was the name? Oh, it should be an array list of U8s. How is that? Oh no, this is not what I want. Oh yeah, this is not what I want. It does not do split lines and read each line into an element of the array list. It reads the whole thing and put everything inside an array list, but everything is just single string. Basically the array list itself is representing this string, I think. So this is not what I want. I will put the allocator in here. Probably we will need this later, but now, and Zig compiler will complain because we didn't use it, so I will do this to it's used. Let's do read until delimiter oh, we actually need an allocator just right here. Okay, read until delimiter alloc will return a this will return a string. Okay, so let's pass the allocator. I always forget my shortcuts. I have a shortcut for hover functions. And okay, the delimiter would be the line. Where is my? Okay, the line and the max size. I would probably need to fix this later, but max int returns the maximum possible amount for that type. And this is a generic function as well, as you see. And I'm saying that I want this to be usize, the maximum possible amount of usize. If this this will read until it reached this count of bytes read. We will not reach this threshold, of course, and it will return it would return a string. Yeah. Why I think I'm doing something wrong? Because if we read this until it did the delimiter, we read one line, we split it, we get necessary stuff, we read another line. Yeah, I think this is cool. So this is our first line. I mark this as variable because you remember that each line in HTTP is both a carriage return and line fit. We already, since we did use until, the line we read does not contain this character, but it contains this one, and we should skip this as well. So I should do first line equals first line, slice it till first line dot len. I think this is cool. So we got our request line. Now we should split it. For some weird reason, it's in mem. I think mem is contains almost all functionalities that you need to work with bytes. I don't know. I really don't know why they put it in here, but split does that. Split is also a generic function, takes a type, gets a buffer, and a delimiter. And this is really nice because you can do other stuff than just splitting on strings. And we are reaching my 1 hour threshold for these videos. And yeah, in the next video I try to type less to achieve more. But now let's continue. We want slice of our U8s to our buffer is first line. The delimiter is \r. No, sorry, it's space, right? Oh, you can. Oh, I'm thinking about something else. Can we read a stream? Can we read a stream until just EOF? Read until, not the delimiter, but just EOF. Read from stream until a specified byte found if the buffer is not large enough to hold the entire content. Blah, blah, blah. If end of stream is found, returns the rest of the stream. If this function is called again after it returns no, returns a slice of the stream. The pointer equal to, let's just continue with our approach. So now, and I think this should be a string, right? Yes. So this will split, and split returns a split iterator. So it's var first line iter. Okay, so first line of HTTP contained method, URI, version. So first line I call the iter. Next, we'll return. This is one of the other one of Zig syntax, we had seen the error returns. This is optional, and optional is either the value after the question mark or null. So Zig is not nullable by default. This is important to know. You cannot just assign null to everything. It should be an optional to take a null. So yeah, and also for null values, there's this dot question mark. So we unwrap the internal thing, so basically we are saying if the value is null, just return error. Otherwise, just return the value. So the first part is the method. We have 3 of them. Second part is URI. And the third part is the version. We are just storing the, for now, we are just storing them as strings. We should probably create types too for methods, some kind of enum, and probably for version as well. So let's read the next line. And next line would be, I can do this. Create second line. Okay, so we got the second line. We should get an iterator for it. Oh, no, I'm doing it wrong, because after the first line, there are unknown amount of lines that contain header. Okay, so we should do something else. We should do a while loop. While true, there are probably better ways to do this condition, but I will just use while true if the line, so we know that headers are ended after we reach when we reach an empty line, just a character return and a line feed. So if we read the line, so let's read the line. Let's read this line. And if this line, let's just call this line. If this line len is just 2 and line equals string of \r\n, we should break our while. Otherwise, we should parse this line. How we are parsing the line? It's simple. We already have the code, so let's just copy it. Line iter. Okay. So for each, and we should split this by colon. So we do line iter dot next. It will first give us the key of that header and the value. Value should be a var. I will tell you why in a sec. Because you remember that we needed a there was an optional space that I was nagging about in here, and we should consider that in our parsing. So if value, the first character of it is space, value equals value1 until the end. So we skip that. This is our value of our header, and if everything goes well, we need to kind of a hash map to store these. So var headers is a standard string hash map. Keys are string, and the values are also strings. you see, this is exactly another one of those generic functions. There are functions that take some content value and returns a new type, and then on that type I can call init, and init needs an allocator because it needs to allocate some stuff on the heap. So if everything goes well, I should do headers.put. Yeah, I should wrap these in a try. Headers.put, and the key is key, value is value. That's it. So, and we break if line is empty line, which means end of headers. Let's see if this actually works, and we probably, you know, put the parsing of the body later, because we actually shouldn't parse the body. We should just put some reader in the request struct that we will create later, and that reader user can try to read from the body, but we shouldn't do it ourselves and allocate memory for it. It's not wise to do that. So yeah, actually let's just echo back what user sent to us. So I hope that this works. So I already have, oh okay, so let's do that. Method is this \n, URI is this \n, version is this, and \n. And then we have headers, that is this, and \n, method, URI, version, headers. I hope that it can, print correctly the headers. So we need to pass the allocator here. Okay. Ooh, we wrote a lot of code without compiling, and that's terrifying. Okay, we have a problem because how this is an error set? I don't know. First line .len here. Yeah, this is because we didn't try. Oh, another one. Exactly the same problem. I don't know why I didn't do it before. Now what? Another problem. Operator not allowed for. Oh yeah. So Zig, you cannot compare two slices with each other. This does not work. There is a method for it. stdmem.eql. Cool. Told you everything that works on bytes and byte slices is in mem, probably. That's right now. Okay, you need compare two slices. Yeah, so I use SU. And I another A type. Okay, next. Oh, every time each next is also giving me some optional value that I didn't handle. So you see that Zig type system is really rich, that it's, handling a lot of errors that could happen in runtime in the compile time for me. So every time I call iter, I should be aware that iter could return null and just iterator would finish, and I could return I could get some kind of null pointer dereference in here, but it's helping with this, and it's not doing it. I'm gonna say this cautiously, but it's not doing it in a way like Rust that make me cry. So this is cool. Run. Okay. Error cannot form. Okay. This is, we reached in here, which is nice. So I know my byte slices of method URI and version are strings. Oh, okay, finally. So it's saying that I don't know how to format a byte slice. Please give me something. I can pass either any or s. There are other formatters as well, but s means just treat them as a string. So if I do nc localhost, it needs some. Well, actually, it will crash. It will crash because end of stream. Okay. We should handle end of stream, of course, but let's just do get on slash on localhost 8080 slash passing some headers. I think how we could pass I think it's dash h. Let's say content type is application JSON. Okay, we hit attempt to use null value because why we have a null value in here for the for the headers? Why the headers is null? So this, you see in main.z line 47, when we want to when we are trying to do handling the, what is 47 here, when we are trying to handle the value of a header. So we read the line, we ignore the last part in here, in here. Let's do, let me just have a, and in here, I want to print. Let's see what line we have. Not here, sorry. In here. Let's see what line we have. Line. Oh, come on, cannot format. Okay. Okay. Let's see. Empty reply again. Oh, we took some of this. Okay. Okay, this empty line means that, yeah, I found that way. So this empty line means that this is not working correctly. So if line length is 2 and std.mem.equal is, so we are not handling the end of the stream correctly. Okay, let me just drink some water, and actually, yeah, let me just drink something here. I'm not gonna do it on stream. Oh, actually it's empty, so we cannot do that. It's almost 1 hour. Let me just check my phone and see if everything is happened. Yeah. Oh, let me answer this one message. Sorry for the disruption. Okay, let's see what we can do about this. So, oh, okay, I got this. Yes, this is the problem. I should put this afterward. Yeah, let's just put that in there. I think this will fix it. I think. I hope. And no, didn't fix it. I don't know why it didn't fix it. Okay. Okay. I don't know what's wrong with this code. The line I read in here is, let's just do this in here. And you know what? I'm gonna just print the bytes to see what bytes are in this line. Okay, so the last line, so you see these, this is one line, this is one line, this is one line, this is one line. this is the last line, and the only character in it is 13. Why? Didn't you say a carriage return and a line feed? You lied to me. You lied to me because, oh, I did go into my private stuff. So you said that, so for some reason, let me bring up I want to see the ASCII code so I know 13. What's 13? Okay, decimal value. 13 is a carriage return. So oh, correct. Yeah. When I'm reading until something, it does not contain this one anymore. It is simple. And it's not almost also 2, it's 1. This should work now. Oh. Oh. So we get a weird response, but actually nothing crashed. So this is cool. So for some reason I should, do some better sending response to the client. So let me just do some cheating and see it in the server side. Yeah, baby, we are parsing it correctly. So we got the method, the URI is correct, the version is correct, yes, and the headers. Okay, headers is a bit weird, but we already saw that let me just fix headers printing as well. This will be useful for us. How we could do this? Headers dot get key iterator over entries in the map. Is there a key iterator? Yeah, iterate over the keys. How we can do that? Okay, you know what, let's remove this from here and here. So we first do this print. After this we do a while. So we create headers over headers header, and we say headers dot iterator while headers either dot next, I think. Yeah, next returns an optional of entry. Entry is probably a key value pair, and there is this syntax in Zig. You can do something called value capture. I don't know where is my pipe operator in my keyboard. Yes, it's in here. Okay, so I get an entry. It will unwrap. So a while on an optional value, it will each time called if a null is if this function returns a null, it will break the while. Otherwise, it will, make the value in here. So entry is an entry. So entry dot, there's a key pointer and a value pointer. Okay, so I will print header values. This. Make this work. Okay. Deref this and deref this. These are pointers, and this is how you dereference in Zig. You do not put the star behind it because it's actually more readable, because I can now continue with this. I don't need any parentheses or something. And every time, just please do, okay, just please do backslash in. Hope this works. No, because as always, we forget this. Let's go here, run this. And yes, everything looks cool to me. This is my problem with typing. Okay. Okay, this actually worked. So git add dot git commit dash m git commit parse http method parse http first and first line and headers and git push. So I think this is the time I should end this stream. And yeah, and this is not a stream actually, this is a recording. I'm planning on doing live stream, but for now I will just record these, and in the next video we are going to parse the body, we are going to create a connection, create a request struct, we are going to figure out if it is async or not, and if it's not, we are going to make it async. And yes, after we did all of these and polish our code a bit about request methods and versions should be enums, if we do these, we can then start thinking about handlers for requests. Before that, we need to figure out routing. Okay. Yeah, thanks for watching, and if you did like this video, sorry for my bad English and some disruptions I had. This is the first time I'm doing this kind of video, that I do this completely not scripted. And if you like this, subscribe and follow me. And this series is not necessarily going to be about Zig, but I think the first few videos are going to be about Zig, but I'm planning to do other stuff as well. Thank you and goodbye.